So in this video, I'm going to show you how to find the power function for the project and also do an example of the Gini index. So this is the data that they have from the US Census Bureau. And the first thing the project asks you to do mathematically is to create this table. So just as a reminder, this project that walks you through 1970, and then you are going to have to do this for a few other years. So I'm going to focus on the percent distribution of aggregate income. And it says, according to this data, they separate it into the lowest fifth, second fifth, third fifth, fourth fifth, highest fifth. And so if you think about, we're talking about percentages, and a percentage, the total is 100. If I divide 100 by 5, I get 20%. And so the lowest fifth is 20%. The second fifth is actually 20 plus 20, which is 40%. And then the third fifth would be 20 plus 20 plus 20, which is 60%. The fourth fifth would be another 20%, which would be 80%. And then the highest fifth would add up to 100%. So our table we're going to create is the cumulative population and the cumulative income. And because it's cumulative, that's why I'm adding each time. So I just pulled 1970. And again, we're looking at this data here. And so for the cumulative population, this column is always going to be the first fifth is 20%, and then it's 40%, and then 60%, 80%, and then 100%. So this is where that cumulative percentages that I was adding before, I'm taking 100 divided by 5, which is 20. And then because it's cumulative, I'm adding 20 each time. So the income, I'm going to do the same idea. So the lowest fifth was 4.1%. And I don't really need to put the percentage sign since it's up here, but you can either way. And then my second fifth is 10.8. Because it's cumulative, I'm adding them. So here I'm adding 4.1 and 10.8 to get this value in my table. Okay, and that gives me 14.9%. Okay, and then I'm going to continue. I'm going to take the 14.9, and then I'm going to add the third fifth, which is 17.4, to get the cumulative percentage. And that gives me 32.3%. And then I'm going to take that 32.3% and add the fourth fifth, which is 24.5. Which is 56.8%. And then I'm going to take 56.8% and add the last highest fifth, which is 43.3. Which is 100. It's technically 100.1 just because of rounding percent, but it should be close to 100. So then from there, my data points are, this is my X value, this is my Y value. I'm not going to write them as percentages here. So I'm going to change them all to decimals. So this is 0.20 and 0.041. This is 0.40 and 0.149. 0.60 and 0.323. This is 0.80 and 0.568. And then the last one is 1.0. Or 1.00 if you want to be consistent with decimal places. And then 1.001. Okay, so this is what they got here. and it should match up with what we have. And they just rounded the 56.3 and the 43.3 to 100%. Okay, and they actually have a typo here. This should be 56.8. They fixed it here, 568, but here they have 56.3. So just know that it's a tiny bit off, and then they rounded this to 100% to make it 1-1. Either way, it should give you the same answer when we do this. So that's how you get your table. So you're going to do that for 2 other years. And then you're going to create this power function. So this you're going to do in your calculator. So to do in your calculator, you're going to enter this data into your table. And to do that, you hit stat and then edit. So stat is right here. Let me make this bigger so you can see it a little bit better. So stat is here. So stat and then edit. And then you're going to enter our table. So let's go back to our table. So we're going to enter these as our X values, these as our Y values, but as decimals, not percents. So on here, I'm going to put 0.2, 0.4 or 0.4, 0.6, 0.8, and 1. And 0.041, 0.149, 0.323, 0.568, and I'll do the 1.001 just to make sure it gives us the same value so that I got here. Okay, so make sure your values match up. Your X values go into L1, your Y values go into L2. So then you go to stat, arrow over to calculate, and you want to go down until you find this, the APWR-REG. So it's right here. You have to scroll down a little bit. You're going to hit enter, and then you want your X list to hit second L1. So make sure that says L1. It probably already does. And this one to say L2. If it doesn't, you would hit second and then 2 to get the L2. And if your X list doesn't say L1, you hit second L1. You don't want anything in frequency. You don't want anything in store. And then you can just hit calculate. And then here it gives you your A and your B. And then this is the general equation for a power function. So a power function is AX to the B. And you want to plug in numbers for A and B. So A, they rounded to 2 decimal places, is 0.92. And B is 1.96. And that's how we get this. Y equals 0.92x to the 1.96. So you're going to do that for 2 other years. You're going to come up with the table and then come up with the equation using your calculator. And then the question is going to say for the Gini index. So this part you can't do until you do the area between 2 curves module, which is in unit 3. But the other part you can do way ahead of that. But I'm going to show you just as an example of how to do this. So we found the Lorentz function. This is what we found here for our power function. So this y equals is the same thing as f of x equals this 0.92x to the 1.96. Okay, the Gini index is this formula where it's to the integral from 0 to 1 of x minus my f of x, which is this 0.92x to the 1.96 dx. Okay, so if I want to find this, I'm going to take the definite integral for this. So for that, the definite integral of x, or the integral of x, is x squared over 2 minus, and then I have 0.92x. When I do the definite integral, I add 1 to the exponent, and then I divide by that new exponent. And because this is a definite integral, I don't need the plus c, but I do need the bounds because I'm going to have to use the fundamental theorem and plug them in. All right, so then I'm going to simplify this. So I get 0.92x, 1.96 plus 1 is 2.96. And then again, this is over 2.96. And then just to make this a little bit easier when I simplify, I'm going to divide the 0.92 by the 2.96 here. And I'm going to put it as a fraction because I don't want to have a rounding error. So I'm going to make this, if I do, let me just show you. If I do 0.92 divided by 2.96, okay, I get a decimal that it doesn't terminate. But what I can do is hit math frac and then enter, and I get 23 over 74. So that's what I'm going to put here. You also don't need to simplify it if you don't want. Okay, once I take my definite integral, then I plug in my bounds and we do upper bound minus lower bound. So I'm going to plug in 1 for all my x's first. And then I'm going to plug in 0 for all my x's. Now, when I do that, you can type all of this in your calculator or you can simplify it in pieces, whichever you're more comfortable with and more likely to get the correct answer. I'm going to type this all in at one time. Okay, so for the first part, I'm going to again put it as a fraction for now, which is 14 over 37. Again, I got the decimal and I hit math fraction. Minus this just gives me 0. So 2 times 0 is 0. So I get this 14 over 37, which is 0.3788 if I do 4 decimal places. Okay, and I didn't include it, but they do have this on the project. So let me just pull up the project for a minute. And so you're going to put that here. So they did 3 decimal places. So 3.78 is what I got if I rounded to 3 decimal places. And so that's how you find the Gini index. So hopefully that helps with making this table. You're going to pick a year A and a year B and then calculate the Lorentz function by using that power function by first creating this table and then using the stat edit and then creating the power function. And then you're going to use this formula to find the Gini index. And if you have any questions, let me know.